Now, you'll see quite a lot of reference to error in measurement, and that's not only in maths, but that's in science as well. It's understood that no measure is ever exact, and there are three main areas where error can creep into a measurement. One is there could be a fault in the device, or even just increments slightly out. There could be the scale on the device is too big. It would be like if I was trying to measure the length of a fingernail and I'm using a meter rule. That's obviously not appropriate. If I'm measuring, even the length of a pencil, and my device has increments that are very big, it's not suitable. And the other thing is human error. If we're not viewing the measurement directly over the top of the measurement, then we introduce a thing called parallax error, and what we see and record won't be the exact true value of the measurement. So we say no measurement is ever exact, and hence we have to take into account the amount of error that's actually in a measurement. Now, there's quite a few technical terms which you have to be aware of. The first technical term you have to be aware of is the thing called the precision, and the precision is just the smallest unit on the device. Now, that will change from device to device. So, let me just see what's going on here. Obviously on this smallest measuring cup, it's going in increments of a quarter, so a quarter, a half, 3/4, and then 1, and maybe the next one is similar, and I can't really tell from the big cup, but you know that it's possible to have different units, even on your ruler. One edge of your ruler might be have the smallest unit as centimetre, and then the other edge has the smallest unit a millimetre. So that's what we mean by the smallest unit on the device, precision. Absolute error is half that measurement, half the smallest unit, half the precision. Now that becomes really important in error. Its name suggests absolute error. And it actually is a measure of how far out. What's the maximum distance, either below or above, that a measurement could be wrong by? So how far out could you be with your measurement? It will always be half the size of the smallest unit on the measuring device. Then combining the measurement and its absolute value gives us the limits of accuracy. So it's the measurement, like I said, it's a combination of the actual measurement, then we add or subtract the absolute error, which is half the smallest unit. Now, if I had a measurement of 7 centimetres, then we know we're measuring in centimetres. So our precision for 7 centimetres, the precision is 1 centimetre. That gives me absolute error of half a centimetre, 0.5 of a centimetre. Our limits of accuracy then is, like it said, the measurement, the 7 minus a half a centimetre, so that's 6.5, or 7 add a half, which is 7.5. and this is the way we write it. So we put the measurement in the middle and we say 7 is greater than or equal to 6.5. We take off the full half a centimetre. We don't say it's equal to 7.5, because if it was equal to 7.5 we would round it up to 8. So it's important to realise that the first inequality will be a less than and an equal, but the second inequality will just be a less than. Okay, so then we go on, and another term you've got to be aware of is this thing called percentage error. The way to get the percentage error is to take your absolute error. Now, what was absolute error? Absolute error was just half the smallest unit on the device. Put that value over the percentage and multiply by 100. So for example, find the percentage error of the measurement 83 centimetres. Again, let's run through all these technical terms. With 83 centimetres, the precision would be, again, 1 centimetre. The absolute error is, again, half a centimetre. So the percentage error, just use the formula, learn the formula, make sure it goes on in your summary. The absolute error, which is 0.5, over the measurement, which was 83, and multiply by 100. And it's a percentage, that's why we multiply by 100. Percentage, multiply your fraction by 100. Let me see if I can get this into view. No, we'll go back over here. And we're doing a fraction. Turn it on. We've got a fraction. And we've got 0.5 over 83. And we're going to multiply by 100. And that's 0.6%. That's pretty small, isn't it? 0.6%. Going to stop the video there. You do your summary, which will definitely include those technical terms, and then you're right to do 502.